Now that there is an understanding of measure of central tendency, let us look at what exactly is the measure of spread, okay, or variability. So it is a measure that gives an idea how spread across the data is, and we'll be having two data set which is having similar. So here in the image we can see that the spread is kind of similar, okay. So considering the x-axis, how it has variation, okay. So this has a kind of almost similar characteristics, so but they are not same data set itself, right? So these two will end up having almost similar or the same mean, median and mode itself, but whereas you can see the spread, it is like one is going up to 1 and other is somewhere around zero point 0.4, okay. So these values are different, okay. So basically we have check with respect to measure of central tendency. So that's what we saw about mean, median and mode when it comes to central tendency. Now let us see about deviation, okay. So basically this is called as the spread, how exactly it is spreading. So that is the basic definition. So next we have we'll take examples, okay. So basically there are two classes with 5 students each. So again here we are taking two different classes of 5 students, and the both scores, where you can see class 1 and class 2 are the same student with respect to the indexes. So basically here we have marks like -10, like maybe you might be thinking what is this minus over here. So this is not a mistake over here. So we have, like, we can consider with respect to examinations having negative marking as well. So like again, why the main reason why I have included a negative integer over here is like working on with the negative numbers also, how exactly it behaves and all. So basically that is -10, and whereas the student 1 is scored -10 on class A and 8 in class B, okay. So then student 2 is 0 and 9, 10 and 10 for student 3, student 4 is 20 and 11, and student 5 is nothing but 30 and 12, okay. So this is the two different marks they have scored. So the mean of both classes we can just find it, okay. So basically the mean of both classes are actually 10 itself, taking like into account that the data set, we can say that the data set are similar. Can we say no? Basically it is not similar. So again we'll take a moment to understand with respect to the scratch over here. So basically we'll find the range of data set, okay. So we'll just check with respect to the data does have differences between the two things. So we'll be discussing the range of their classes. So the range is nothing but the maximum value minus the value of the particular range of their duties for the class of the minimum value, okay. So that is nothing but 30 minus 10. So you can see here range is going with respect to 40. So this is the 30 is the highest number, -10 is the lowest number. You can just subtracting it, and when it comes to range of 2, you are getting something like 12 minus 8, okay. So basically it is varying. What is the fluctuation between, or the range? So we had seen the graph, right? So one is varying with respect to 0.4 and other is going till 1.0. So similarly here the range is like from -10 to 30. It is actually varying from 40 units, okay. So here we can tell the 40 unit spreads for class 1, okay. So the class 2 on the other hand is nothing but 4 to be particular. So for this particular range, we can see that the range is pretty good idea to how like to see with respect to square, okay. So when we check with respect to mean, again it was the same 10 for both classes over here, okay. And next, like the why range is in the best way to understand the spreads. Again we have as I was mentioning the standard deviation and variance, we'll be seeing that. So like we saw earlier that times the method will also fail with respect to giving correct interpretation of the data set. There are some ways to find out with respect to the range, okay. So basically here like why exactly range is not the best way to understand is like maybe you can consider like giving data, okay. So the data might be coming from not maybe not numeric data set, but categorical data set. Over there you can't find data. So basically we will be getting we won't be getting correct interpretation of the data set. So the range is no different. There might be cases where the mean of is same than the data set. So basically previously we saw like 30 and minus 10, so that is a wide spread of range. Okay, so the mean in the same way we had seen with respect to an outlier. Okay, so is the same, the data range is same, but the values differ, telling us that the data might have different spreads. Okay, and if we go with the ranges all the time, we might end up with completely different interpretations. Okay, so basically even we had negative numbers, positive numbers with respect to class A and class B, but ultimately mean is same. So similarly we had spread also kind of very light range. So here that's why we come into picture of variance. Okay, the symbol over here is a Greek uh, letter known as sigma. Okay, so sigma square. Okay, it is not 2, it is actually square, so it should be superscripted over here. So what exactly is variance? Okay, so variance is like the name only tells, it's the variation, or the variation, or it is like the where exactly it is moving further. Okay, so it is a measure of how data points differ from the mean. Okay, so we'll be having mean like exactly what we did in range also, but here we won't be subtracting from the highest to lowest, rather we'll be subtracting from the mean. So according to a scientist known as Layman's, so in terms it is a measure of how far a data set, or how far a set of data are spread out from the mean, or from its average value. Okay, so that is nothing but the variance. Okay, so basically this will be the formula, and also we'll be taking square of it and divided by n. Okay, so the formula here is nothing but sigma square is equal to summation of x minus mu. Okay, so here basically mu can be considered as uh, the mean. Okay, so mean or x bar. In the below one you can see it is like x bar and whole divided by 2. So here it will be divided by 2 number of ones, or you can do n minus 1 if you are going with respect to the starting the of the number with 0. Okay, so that is a basic formula example. So to understand better, so again we'll go back with the same kind of example. So there are 2 classes with 5 students each. The obtained marks are as follows. So we have the same number of values over here, and next is finding out the variance. So here with respect to variance you have something like minus 10, minus 10. So mean is 10, right? So 10 minus 10 subtracted by 10. Okay, so 0 subtracted by 10, and it is multiplied by individual this one. So that is nothing but 2. Sorry, it is not 2 over here, so my apologies. So this is square above. Okay, so this is the square. In the previous formula also we had seen square, right? So in the previous slide with respect to formula, here we have square. Okay, so we are doing sum of it. Okay, so that is square. So taking the square of it divided by number of students, that is 5. So basically we'll have 1000 divided by 5, so that is 200. And when it comes to this one, class 2, you will get somewhere around 2. Okay, so this is the average variance. Okay, so let me get this division symbol. Okay, so this is the average. So even now, like the difference where we saw about mean, both classes showed the same property, whereas when we went with respect to the range, okay, the spread, we had something like 40 and with respect to 4. Okay, so but here we have a huge difference, like 200 divided by 2. Okay, so this 200 and 2. Okay, so class 1 has a variance 200 and class 2 has 2, but this is also not like more accurate. So for that reason we go with something known as a standard deviation. So that is nothing but root of variance. Actually this standard deviation is nothing but root over variance. It is the quantitative expressed by how much the members of the group differ from the mean. Okay, so it is not just the value, but in spite it is the group differs from the mean for the group. Okay, so this is the formula again, the same variance formula where it is taken with respect to the root. Okay, so that is standard deviation. Again, going back with the same example, if you consider the same data set, finding out variance and then taking root of it. Okay, so this is a standard deviation, not variance over here. So ultimately taking root of it. So here it is like 10 root 2 and here root 2. Okay, so let me just get the so basically here it is like 10 root 2 and here root 2. So now we can tell standard deviation of class 2 is 10 times lesser than class 1. Okay, so this is what you can tell. So like the students are randomly understanding, where there is more consistency of understanding between the students with respect to any kind of topic is the root 2. So that is not much deviated for class. So whereas class 1 is widely deviated. So with respect to this standard deviation, now you can tell the students like like you understand how exactly the students are understanding, right? So with respect to the marks only, the deviation is quite large. So again, with respect to mathematical calculation, it is just a root of variations. So that is with respect to standard deviation. And also, like, we already found variance. Why exactly we need standard deviation? So what is the problem with the variance? Okay, so taking the previous example, like the example which we just saw moments ago. So taking the previous example, we see that the values for the class are marks. Okay, and now when we take the variance, it considers the final form in terms of mark square. Okay, so we was taking square of it. So mathematically speaking, which doesn't make a lot of sense. So that's the reason we have standard deviation as calculated over the variance. So definitely, if you are going with respect to calculation of standard deviation, you have to calculate first mean, then get deviation or variance of individual ones. So those variance, and then you can find out taking a root of variance would be standard deviations. So those are all the descriptive statistics which I wanted to discuss. So again, if you are thinking about more about the statistics, the topic goes on even. The topic is really vast. So again, we have covered only what is with respect to basic understanding and necessaries when you are doing the calculation of anything manually. And when it comes to, again, even if you are not, like, you might be wondering now, how will we find out standard deviations of a data set which has thousands and thousands or lakhs of data. So again, need not to worry, since we have very powerful machines tools where we'll be doing the project. So basically, we'll be working on Python, right? So Python, I hope everyone has understood how fast Python is and how quickly it can do a lot of data. So basically, even we had done like kind of loops. We went through loops. So loops also were executing within seconds, right? It was not even seconds. So the system is very fast. So hence all these calculations will be taken care of that. But we need to know the concept before applying, right? So again, further down with respect to learnings also, we have different kind of learning. So to implement, we need to know the difference. So without knowing what exactly standard deviation and ultimately getting output of it will not make much sense. So that's why we are covering up all the basics. So this is about the descriptive analysis. So in the next video we'll be in the next topic we'll be covering up with respect to probability. So that's all with respect to descriptive statistics. So that is the measure of the measure of central tendency and the measure of spreads.